L'Hopital rule in single variable and multiple variable. Okay, so we are pursuing discussion in L'Hopital rule in single variable case and multiple variable. What is L'Hopital rule? L'Hopital rule says that in case someone is landing into a situation of 0 by 0 case or infinity by infinity case, then there are ways where he can use some workaround to come out of the undefined state. What is undefined state? Okay, consider that there is a function called function over x, f in bracket x bracket code. Function over x is equal to an algebraic expression. And what the algebraic expression is x minus sine x divided by x to the power 3. X minus sine x divided by x to the power 3. If this is the case, then if x equal to 0, at that point it will become 0 by 0. What is fx? First of all, what is fx? Fx means at any x, what is the height? That is called fx. Okay, what is height? What is at any place? People would be thinking. Okay, fx means. Okay, what is the height and what is this concept? People would be thinking. Fx means consider this is x-axis. This is x-axis. This is x-axis. This is minus x-axis. X. This is origin, and this is plus x-axis. This is y-axis, and this is minus y-axis. Now I have a graph like this called function over x. Makes sense? What is the equation of your graph? X minus sine x divided by x to the power 3. Consider x equal to pi by 2. Then it will become pi by 2 minus sine pi by 2. Pi by 2 minus sine pi by 2 will become pi by 2 minus 1 divided by pi by 2 to the power 3. Okay, if I take any value of x, then what is fx? Consider, okay, I don't know what the actual graph is, x minus sine x by x to the power 3. If I take any value x, this is origin. I take any value x, at this x, if I draw a vertical line, any value origin, and from here, this is x-axis. At this point, if I draw a vertical line, this vertical line is going to hit this fx at a point here. This is called x and this is called fx. If people are curious to understand what is the concept behind fx, then on x-axis I have any x, and at this x, if I draw a vertical line, at this x, if I draw a vertical line, then this vertical line is going to touch this point at a point called x comma fx, where x is the horizontal component and fx is the vertical component. This is fx and this is x. Okay. Now this point is x comma fx, means this is the height. Understandable? Now you keep varying value of x. X is consider x is minus 1. Then x minus sine x divided by x to the power 3. Minus 1 minus sine minus 1 in radian divided by minus 1 to the power 3. Okay, keep changing x value in numerical and keep getting different fx, means different height. Now consider that there is a point called origin, x equal to 0. Now someone will be curious to know, tell me what is your height of the curve x equal to 5? What will be the height? Height will be, if this is x equal to 5, at 5 you draw a vertical line, and this line height is function over x at x equal to 5. Makes sense? Means 5 minus sine of 5 divided by 5 to the power 3. I believe the height will be very less. Okay, this is how it is. Someone would be curious to know that what is the height when x equal to 0? Then answer is 0 minus 0 divided by 0, that is 0 by 0. Okay, tell me what is the height. Is it infinity? No, it is not infinity. Is it 0? No, it is not 0. It is negative, then it is not negative. It is 0 by 0. What is 0 by 0? Infinity? It will go infinity? No, that I also don't. It is undefined. I cannot tell you what the height is. How come you cannot tell me the height? Anyone can draw the sin x minus sin x by x to the power 3 graph. Anyone can draw. Okay, certainly this graph, I believe this. Okay, let's try when x equal to zero point 0.1. So we have zero point 0.1 minus sine of zero point 0.1. Sine of zero point 0.1 is more or less I can consider 0, 0. So zero point 0.1 divided by zero point 0.1 to the power 3. Makes sense? It will become, I believe, 100. 100? Okay. 100. If I take sine, okay, it is x minus sine x. Sine 0.1 will be tends to 0. So it will become 0.1 divided by 0.1 to the power 3. 0.1, 0.1 gone. 0.01 opposite will be 100. So height is 100. Means this, okay, let's try when x equal to 1. Then 1 minus sine of 1. Okay, pi by 2 is how much? 1.5. When sine of 1.5 around or some 1.6 or something like that. Sine of pi by 2 is 1. Then sine of pi by 4 is 1 by a square root of 2. Okay, so how much it will be? I believe it will be around, it will be sine 30. I think so. Sine 30 is 0.5. 0.5. Okay, sine 60, I don't know. I believe it will be around zero point 0.7 or something like that. Sine 1, sine 1. 0.7, 1 minus zero point 0.7 divided by 1, that will come as zero point 0.3, zero point 0.3. Means at x equal to 1. Let's try x equal to minus 1. Minus 1 minus sine of minus 1. Sine of minus 1 will be minus zero point 0.7. Minus 1 plus zero point 0.7, that will come as minus 0.3 divided by minus 1, that will come as plus 0.3. Okay, more or less it came as 0.3 again. Means this is a graph what we are trying to calculate at x equal to 1. X equal to 1. What about x equal to 2? 2. Okay, then 2 minus sine 2. Sine 2 will be a more or less zero point 0.7 again. It will go back after pi by 2. It will be to 1.3 by 8. Means it will start decreasing. It will start decreasing. Sine, okay, sine minus 10, minus, sorry, f minus 10, minus 10 minus sine 10. Okay, let's try 4. Okay, if I try 4, then let's try minus, okay, minus pi, minus 2 pi. How much is 2? Pi is, I believe, 3 point something. 2 pi point is 6.7 or something like that. Take 6.71, then it will be sine 2 pi minus sine 2 pi, whatever, it will be 0, 1. If I take minus 7 divided by minus 7 divided by minus 7, it will be plus and it will be tends to 0. Understandable? Okay, looks like the graph, if I draw, the graph will be like this. More we go in x, it will be tends to 0. So the graph will be like this. More we go and more we come near to the origin, it will be go up. Makes sense? And this side also, negative side of the x, it will be up at x equal negative side of the, if this is origin and this is minus x axis, then it will go up, go up, and when I go toward the minus x infinity, then, so it will be like this. So it will be a graph of like this. Means at the origin it will try to grow up, 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 up. Okay, but the scenario is rather than going to infinity at x equal to 0, it is coming 0 by 0. Now, there can be many scenarios. One scenario we were talking about how much error. L'Hopital rule. L'Hopital rule says that do one thing. You calculate the differentiation of these. Okay, first it is saying that if you have x minus sine x by x to the power 3, consider that numerator is a separate function and denominator is a separate function. Don't consider full as a one function. Consider both are separate functions. If you consider both are separate functions, the numerator is like hx and denominator is gx. The way we said hx is x minus sine x and gx is x to the power 3. Draw the graph separately. For hx, you draw the graph separately, and for gx, you draw the graph separately. When x equal to 0, then hx will be 0. When x equal to more, then hx will try to grow like this. When x equal to 100, sine x will be between minus 1 and 1 only. So it will be like 100. So x will go more or less linear only like this. If this is origin, this is x-axis, x will go like linear only, something like that. Okay, what about gx, x to the power 3? It will go like this. Okay, the concept is x, if x is like this and gx is like this, if I divide the height of these two, height of at any moment, what is the height of hx? The height of at any moment x, the height of hx is x minus sine x. What is the height of gx? That is x to the power 3. For height of the gx, how much is the height of hx? This is hx by gx. This is what we are trying to say. Anyway, if that is the concept, at x equal to 0, hx is 0, gx is 0, or we are coming to undefined case. Sir L'Hopital is saying, take the derivative of hx and gx and try x equal to 0 again. If I take derivative, then it will become, if I take derivative, the concept behind it is Cauchy mean value theorem. Okay, if I have two curve and you have two end point, then end point slope division will be same as in between there will be one point at that point tangential slope division it will be. I believe quickly I can say. If there is a graph like this called x minus sine x and there is a graph like this called x to the power 3, if I have two end points, consider one end point is x equal to 0 and another point is x equal to x. Then in this graph, if I take, okay, consider this is the graph of the hx, x minus sine x. If I take one point here called x comma hx and another point here called g comma h0, sorry 0 comma h0. If I connect these 2 points through a straight line, then a straight line will have a slope. Similarly, I have gx as x to the power 3 at same x. Same x I tried with hx, same x if I draw a vertical line, then it is going to hit this gx. It is going to hit this gx. If I draw the from 0 and x, if I draw this is gx, x to the power 3. If I draw if I connect these two end point, then this line will have a slope. Understand? Hope I think this is better. This is x to the power 3. If I take any x here and draw a vertical line like this, it will touch here. And one point is x equal to 0, one point is x equal to x. If I connect these two end points, I have a line with a slope. I have a line with a slope. Slope means angle with the x-axis tan theta. I have another line called x minus sine x. If I take same x and connect two end point, I will have another line which will have a slope. If I divide these two slope, then you remember it. What I have to remember? You have to remember hx minus h0 by x minus 0 divided by gx minus g0 divided by x minus 0. Hx is the height at x, gx is the height at x. Understand? Okay. Now there will be a point between origin and x that is called C, and that point, if I calculate the tangent of both the curve, if this curve is x minus sine x, then at point C, if I calculate the tangent, And then this is another curve called gx, x to the power 3. And there, if I calculate the tangent again, and these two tangent slope, if I divide that, they will be equal to the end point line slope, means hx minus h in bracket x bracket close, hx minus h0 divided by x minus 0 whole divided by gx minus g0 x minus 0 will be same as dhx by dx, because derivative at any x equal to c will give the slope of the tangent line. Dhx by dx at x equal to c divided by dgx by dx at x equal to c. If I constrict this c, if I constrict this x, what we are talking, the way I start moving, okay, if I start moving x toward the origin where we are seeing the undefined case, if x is here, then c is here, where we are seeing the division of the gradient. Okay, if x is here, c is here. If I bring x near, then c will be in between only. If x is here, then c is here. When x is here, c is here. When x is overriding a 0, then c will be at 0 only. This is the concept. If that is true, if that is true, then at x, then anyway, now we have g0 is 0 and h0 is 0. X by minus 0, x minus 0, they also go away. It will become hx by gx, where x tends to 0. X we are trying restricting toward the begin point. Hx by dx at x tends to 0. If that is the case, then dgx by dx, dhx by dx divided by dgx by dx, x tend to c, where c will tend to 0 again. Means hx by gx at x equal to 0 will be same as dhx by dx divided by dgx by dx at x equal to 0. Anyway, so as per the L'Hopital rule, what is coming to solution is, whenever you are in problem, then you calculate where at point where you are in trouble, at that point you calculate the first derivative and set the x equal to 0 again, or wherever you were seeing the undefined. Anyway, now if I see like this, then it becomes 1 minus cos x divided by 2x square. If x equal to 0, then it will come a 0 by 0 again. Okay, this is called one stage of L'Hopital rule. Second stage of the L'Hopital rule is, consider you have a function called 1 minus cos x as numerator and 3x square as denominator. So hx is now turned into 1 minus cos x and gx is turned into 3x square. Okay, now try again. If that is the case, then we will take one more derivative. Anyway, we will keep doing this till setting x equal to 0. It does not result in undefined case, 0 by 0 or infinity by infinity, something like that. Now question is arising, how much error the L'Hopital rule is making when we are going derivative by derivative. The previous session we talked about that if I don't think about Cauchy mean value theorem, on what theorem the L'Hopital rule is based upon. L'Hopital rule is based upon a concept that if I calculate the derivative of numerator function and denominator function, derivative should be constant. It should not be dependent upon any point x, like x by minus x. Derivative will be 1 by minus 1. In that manner, derivative is not dependent upon any x. If that is the case, then everywhere division of the derivative is same. Like x square by minus x square, derivative will be 2x by minus 2x at x equal to c. C means 2c by minus 2c, c gone. Division of the derivative 2 by minus 2 is not dependent upon x equal to c. Anyway, as per the Cauchy mean value theorem, now if I bring Cauchy mean value theorem, then hx by gx is equal to derivative of hx and gx at the point where problem is there. But derivative is not dependent upon the any point. If that is the case, then everywhere hx by gx has to be constant and everywhere it has to be same. If it is not varying like that, if it has to be same, then why it will be 0 by 0 or infinity by infinity at a particular point? If it is showing that nature at a particular point, then replace it with whatever you are getting at other point. Now from here only, everything is spanning over. More and more you go, then more error. So how much? Now person has to think how much we error we incur if I go derivative by derivative. And now if I go x minus sin x by x to the power 3, first derivative will say 1 minus cos x by 3x square. Second derivative will say it is sin x by 6x. Third derivative will say it is cos x by 6. Cos x by 6, if I take, then it is dependent upon x. It is not constant. Cos x by 6 is not, consider it was constant. Cos x by 6, rather than it is coming as cos x, it is rather than coming as cos x, it is coming as some constant. If it is coming as some constant by constant means third derivative is not a variable. Okay, if it is not a variable, then before the third derivative, what was the equation? Before the third derivative, equation was sin x by 6x. Before the third derivative, the equation was sin x by 6x. Okay, means the sin x by 6x, if I take the curve, then this curve is valid everywhere and it has a fixed division of derivative. Okay, in that manner at x equal to 0, same thing will come into the picture. But this is not the case. Sin x derivative is cos x, 6x derivative is 6. Denominator is constant. It is not varying anytime. Numerator is varying. If numerator is varying, means differentiation is varying with the x. Differentiation is, so it will incur some error. It cannot be free of the error. Okay, free of the error is only when the division of the differentiation is independent of the x. In that manner, your division, that is hx by gx, should be always same thing. Okay, means why it will be different for 0, x equal to 0 or x equal to a or something like that. Whatever you are seeing, same thing, that you have to replace it. Anyway, we will see this error. Little bit today we will start discussion on the 3D model. What is 3D model of the L'Hopital rule? I believe people understand it. If I go differentiation by differentiation and we reach to a condition where it is coming as constant by constant, but that constant by constant will come for the previous equation, not the original equation. For original equation, if I see, then it is coming as a variable, but it is again 0 by 0, so we are differentiating again. Okay, if I am differentiating again, then it is coming again as variable. I am differentiating again, it is coming as a constant. So previous one where it was variable by variable, it is perfect L'Hopital rule for that case. Understandable? But for not for the beginning case, how much error it is giving. Anyway, we will talk about little bit about multivariable case. What is multivariable case in L'Hopital rule? So multivariable case in L'Hopital rule says, consider this is xy plane. Consider this is xy plane. If this is xy plane, then this is okay. If this is xy plane, consider this is x-axis, this is y-axis, this is xy plane. If this is xy plane, then above the xy plane, I have a 3D shape. This is a 3D shape. 3D shape has surface or 3D shape has a volume. Understand it? Now consider I have any point here at x comma y or point A. There is a point called A. If there is a point called A has x component, A has y component. This is origin. This is x, this is y. Together they make a point, they make a point called x comma y or A. Now above A, I'm drawing a vertical line. Makes sense? Now above A, I'm drawing a vertical line. This vertical line will go up. This vertical line will go up and it is going to hit the surface at this point. Consider it is going up. There is a 3D shape above the XY plane. This is I'm talking about L'Hopital rule in dual in 3D case. So at point A, I'm drawing a vertical line. It is going and hitting here. Okay, what is the height? Okay, it has to touch somewhere on this 3D. Now what or consider question is what is the height? At any point A, at any point A on XY plane, what is the height? Then height will be F in bracket A bracket 4 function over A again. If A is x comma y, then it will be f in bracket x comma y. Can you tell me an example? Example can be fxy equal to x square plus y square. This will form typically a paraboloid. This can be considered as a paraboloid. Okay, paraboloid is this point. Okay, x square plus y square. Now the question is arising. Consider I have fxy function over x comma y is equal to x square plus y square divided by x into y. Understand? X into y. Someone will say thank you very much. What is x into y? X into y, if x square plus y square is the equation of a paraboloid shape. Okay, paraboloid shape means if I keep y equal to 0 and move in x-axis, then it will grow like this, the way parabola grows. If I keep x constant and move along y-axis, then it will grow again in parabola. These two, if I combine, it will become a paraboloid shape. Okay, another is x into y. If I keep y equal to 0, then along x-axis there won't be any height at all. If I keep x equal to 0, along y-axis there won't be any height at all. Maximum height I believe we will get when x equal to x and y equal to each other. Means along the line that is I plus j. There we can see maximum height. Otherwise, height will be reshaped with the equation x comma x into y. So I have f x comma y equal to x square plus y square divided by x into y. Makes sense? Now tell me what will be the height of this curve? Okay, this is the full equation. Paraboloid is separate and x into y is not, these are not separate. I said like a separate thing, that is true. But all together they are making a different 3D shape. Consider x equal to 1 and y equal to 1. Then numerator will be 1 plus 1, 2, denominator will be 1. The height of the curve will be 1. fxy means at x comma y, if I draw a vertical line and it is touching the surface, what is the height? That is fxy. Similarly, I talked about the fx. Similarly, it is for fxy also. Now when x equal to 0, y equal to 0, what will be fxy? The answer is 0 plus 0 by 0. Again, it is undefined. So in multiple variable case, there is also case of undefined case, that is 0 by 0. Or if it is 1 by x square plus 1 by y square divided by 1 by x into 1 by y, x equal to 0, y equal to 0, it will come to infinity by infinity. Otherwise, it will never come to undefined case. Never. X square plus y square by x into y. They will never come to undefined case. Only at x equal to 0, y equal to 0. What L'Hopital rule can be applied here so that person should not be in panic? Because he is saying everywhere it is defined. How come at only one point it will not be defined? That is the question now. Now to solve it, what is the L'Hopital rule that we can think about where it is going to solve our problem? Anyway, so we will proceed more on this, and that is the 3D case. I believe it will come as interesting. Okay, is it df? Now Now someone will say you have to do same thing. Fxy equal to hxy by gxy. That will be equal to, first that will be equal to a slope of hxy by slope of gxy. How similar to what we did in the single variable case, how we can proceed in the multiple variable case. So that scenario that we will see. Please don't mind supporting us. +91 is the India country code. Okay, we will use vector and parameterization concept, the what we did in the earlier session. Okay, that we will reuse here. Anyway, +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610.